Here's another example. I'm going to solve for B, or we can solve for A. Either one, it would be the same process. Let's try to solve for B in this problem here. All right, I want to get the A all alone on one, B? Let's get the B all alone on one side. First thing I notice, I have this denominator here. I want to get rid of this fraction somehow. So what I'm going to do is I'm going to multiply both sides by A plus B. Whoops, wrote that twice. So I have A plus B over 1. Notice I have a number in the numerator and in the denominator. A plus B divided by A plus B is just 1. So you don't cancel, you don't remove it. You're not canceling things really. You really not realize that this is a 1. So I'm getting rid of these because it is 1. Now over here I have AB times 1, or just AB. And over here I have R times this stuff. So I have AR plus BR. Now I'm trying to get B all alone on one side. I notice it's B's over here and B's over there. Might as well put all the B's on one side. So I'd subtract BR from both sides. Right? And look what's happening here. Ooh, I'm getting AR equals AB minus BR. I'm going to rewrite this as AR equals AB minus RB. And notice I can pretend this is kind of like suppose I had 3B minus 4B. You know if you had 3B minus 4B, you'd end up with 3 minus 4 in front of the B, which is negative 1B. Well, the same thing here. I'm doing A minus R because I have AB's here. I'm taking away RB's. I'm going to end up with A minus R B's. Right? Almost done? Now, what would I do if I had negative 1B equals like 7? Divide both sides by negative 1, wouldn't I? Well, same thing. Ready? I have something in front of the B. I want to get rid of that coefficient of B. Here it's just, it's a little expression, A minus R, but that doesn't mean I can't just go like this. Cancel it out. What do I get? B equals AR over A minus R. How awesome is that, dude? The power of algebra is something that you can use all the time. Yeah. All right, one more. This one's a little tricky. Let's solve for little r. Whee! Same thing I got going on here. I got K times this whole thing. So let's see. I have C equals, this is like a K over 1, so really what I have is KRR over R minus R, small r. Well, again, we're going to use this, we're going to multiply both sides by R minus R, just to get rid of the fractions. We want to get rid of these fractions. The least common denominator here is that, the only denominator. And this equals 1. I end up with this nice equation now. K, big R, little r. And over here I have CR minus C, little r. Okay? Now, I want to solve for little r. That's what I'm trying to solve for. So I want the little r all alone. How am I going to do this? Little r all alone? Well, let's get them all on one side. Let's add CR to both sides. And I end up with, I want to get the little r's all on one side, right? CR equals KR little r plus C little r. Well, look at, notice, can I consider those coefficients of little r? And if I had like 4r plus 6r, wouldn't I just get 4 plus 6r? Hey, you know it. So I'm going to rewrite this as CR equals KR plus C little r. Divide both sides by KR plus C, KR plus C, and I get my formula. R equals C big R over K big R plus C. Solve for little r. Magic? No. Algebra? Yeah.